Hello all, let us talk about overvoltage and several scenarios associated with overvoltage. So first of all, let us try to understand what could be an overvoltage. So when we say overvoltage, it is basically the voltage level by which the input supply voltage or any digital voltage has exceeded beyond the expected level. So example, if you see the diagram here, a system is expecting a 9 volts and then the tolerance of that voltage is around 10 volts, which is provided as per the specification. So when we say specification here, and as mentioned in the specification, any voltage beyond this could lead to failure of the system. So that's what our input voltage and its tolerance meant. So example, if we take a 9 volts and a tolerance of 10% here, that means 9 plus 10% into 9, which is nothing but 9.9 volt is the overvolt is the voltage that can be that is allowed for this particular system. So any voltage beyond 9.9 volt is always a over voltage for this system. Now understanding this scenario, let us go to the different scenarios associated. So the next point is, what are all the over voltage scenarios that could occur? So the first thing, if we say 9.9 volt is the over voltage, maximum voltage that is allowed, any voltage beyond 9.9, example 10.5, 11, 12, to that particular system or any system which is provided an input beyond its specification as a continuous DC voltage is a voltage over voltage scenario. And to understand another scenario, over voltage is not always a continuous DC input. It could be a voltage fluctuation, which is a ripple. That's what you see here in the on the right side. So that means there is a fluctuation of the voltage on the DC, which we call it a ripple. So this ripple could cause a overshoot on the DC voltage, which can go beyond 9.9 volt. While this is not so dangerous, but over a period of time, for a IC, for a system operation or any IC operation, it is better we eliminate this ripple because we are giving beyond the voltage. So for a design engineer, there is generally a question. Example, if we have an IC and the IC manufacturer says 5 volts is the operating voltage, and the maximum voltage that can be given is 5.5. So someone might come and ask, if I give 6 volts, what would happen? So that is a question. Even the IC manufacturer sometimes doesn't provide any data because these are all ICs which are tested to perform within their specifications. So if you give beyond that, directly the IC manufacturer says it is not recommended to use. So as a design engineer, we are using those ICs and we are providing inputs. So it is better that we use them within the specifications, and while there would be some other protection mechanisms that will be involved in the IOs of the digital circuits, but it is not preferable to provide any over voltages. And then continuing beyond the ripple here, another over voltage scenario is a ESD. ESD is nothing but electrostatic discharge, which is the static voltage that gets passed on to the electronic devices when we hold them. That is called a human body model. So you can see the kind of waveform where there is a sudden peak current that flows through for a period of few nanoseconds, and so this spike is very dangerous and it could damage your system. And then there is one more over voltage scenario which is called a surge. Surge is again it is for a brief period of time. It is more than the ESD, and this occurs because of any sudden load transients that happen. And the one more scenario is the transients, which we call electrical fast transients. So again, this is also because of the switching. So the difference between surge and electrical fast transient is basically surge occurs at a specific point of time, and it may not be continuous, whereas electrical fast transients are pulses which occur at regular intervals. So if you take automotive domain, the load dump pulses or whatever we talk, as per the standards ISO 7361-2, or the transients as per ISO 16750-2 are examples of the transients. So you can go to the standard to see the amount of time and amount of the peak current that flows through, the amount of voltage basically, which is allowed as per that standard. Now let us see what are all the different protection mechanisms for these scenarios. The first thing is protection from a simple over voltage. So this we are talking about a supply voltage or protection on a IO signals. For example, if you take a analog along with IO, so that is one scenario which we are going to protect from. So here, if you see the left one, V is the voltage which we are giving to a load R. So in between you have a circuit which does the over voltage protection. So this Q1 basically is a switch, so which isolates the voltage from the load R. So this switch Q1 is basically switched when there is a over voltage protection. So example, let us assume the over voltage is around 5.1 volt and the D1 should be 5.1 volt. So below 5.1, this Q2 will be off, and then Q1 will be on, because this will be grounded through a resistor and there will be voltage going. When voltage goes beyond 5.1 volt, this diode pulls this transistor low through R3, and then directly the supply is provided to the base of the Q1. So to base of Q1, when you give positive voltage, this transistor will be off. So that's a simple operation which can be used to protect your input voltage. So depending on the kind of requirements, we have to tailor this circuit, but this is a simple way we can protect. And there is one more protection mechanism, which is a Zener diode, which is used across devices like interfaces like analog inputs. So example, if you have an analog input which should not go beyond 5 volts, so we'll use a Zener diode for specific rated voltage here, so that any voltage beyond the maximum voltage would be clamped by this diode. So this you should have a series resistor here, such that you will have appropriate current limiting that is done, so that this diode will not be damaged. So this is just indicative purpose. So these are the two different over voltage scenarios which can be used. And then the another over voltage scenario which we talked is the electrostatic discharge. So this electrostatic discharge could be three types. It could be a human body model, it could be a machine model, or it could be a charge device model, which we call HBM, MM, CDM. So the voltage, kV of voltage, varies between these different models. So on the right you see the sample ESD waveform here. So for this, TVS diodes are generally used. So if you have any external interfaces to your board, whether the connectors for the IO or the serial interfaces, or the power supply, or any LCD kind of scenarios, you should have USD protection, because there is always a chance that you plug in connectors and you handle them with your body. So the static discharge on your body could pass through the circuit. And then other ESD scenarios could be which could be internal to the microcontroller. So all the microcontrollers have a protection on those pins where you can see here D1 and D2 are the protection diodes which are connected between VDD and VSS. So this is one scenario. And then at power supply inputs or any I/O interfaces, as mentioned, there could be TVS diodes that could be connected. So these are the simple protection mechanisms which are used and standardized. These are actually standardized mechanisms where every circuit follows, and these days protection against ESD is mandatory. And then protection from surge and transients. So particularly I have been a favorite of this surge protectors from previously linear technologies, which is now taken over by analog devices, and they have a very good over voltage, under voltage and surge protection mechanism, which also includes overcurrent protection as well, which controls a series FET. These are very useful devices, you can see them. And as we said, these transients could be from lightning, which is a huge energy that is being given at the input of the devices. So to pull such energy to devices, we need components like MOVs, which help to eliminate these transients. And then once the voltage is lowered, you can use a TVS. So these are the protection mechanism for surge and transients. There could be other options available, ICs available from different vendors. You can check the respective websites, but these are the simple mechanisms. So hope we are clear. Please let us know if you have any questions. Please post any links or any other protection mechanisms you know and you have used in your circuits, so that everyone will be aware of this. Thanks for watching. Please like our video. Please subscribe our channel. Thank you.